Welcome, space enthusiasts. Before we dive into today's incredible cosmic journey, I have a quick favor to ask. If you love unraveling the mysteries of the universe, and this video sparks your curiosity, please hit that like button. It genuinely helps our channel reach more astronomy lovers around the globe. Also, make sure to subscribe so you never miss our future explorations of the cosmos. And most importantly, drop a comment below, letting me know where you are watching from today. Are you tuning in from New York, London, Sydney, or maybe somewhere in Africa, or a remote island? How far across our own planet has this video traveled? I absolutely love reading your comments and seeing our global community come together. Now let's begin this unforgettable journey. Look at this early photograph of Andromeda, captured by Welsh astronomer Isaac Roberts way back in 1888. What do you see here? Well, if you were a scientist of that era, believing that the Milky Way constituted the entire universe, you would likely say you are looking at a glowing cloud of gas. Perhaps it was a snapshot of a newly forming solar system. Whatever it was, this structure had to be part of our Milky Way because everything out there was considered our universe. However, there were always a few mavericks who disliked this idea, offering a radical and somewhat bizarre explanation. Maybe this photo showed an entirely different galaxy, a separate island universe, just like our own. This heated debate climaxed in 1920 during the famous Great Debate between astronomers Harlow Shapley and Heber Curtis at the Smithsonian National Museum of Natural History in Washington, D.C. Shapley argued that these spiral nebulae were small and located firmly within our Milky Way. Curtis countered, pointing out that more novae were observed in the Andromeda Nebula than in other parts of the Milky Way, a fact that couldn't be a mere coincidence. Curtis also noted that Andromeda's dark dust lanes closely resembled the dust clouds within our own galaxy. He firmly believed these nebulae were island universes, a term originating from the philosopher Immanuel Kant. The argument was finally settled by a young Edwin Hubble. He famously pinpointed Cepheid variable stars within Andromeda's disk, calculating their distance to be over 1 million light-years away. When Hubble presented this astonishing distance at an astronomical meeting in 1925, he received a standing ovation. It was the farthest distance ever measured, definitively proving that Andromeda was a completely separate star system. This simple observation of fluctuating starlight shattered our previous cosmic boundaries, proving the universe was vastly larger than the Milky Way. Because Andromeda is visible to the naked eye, especially in ancient, light pollution-free skies, it's hard to say who truly discovered it. The first recorded mention belongs to the Persian astronomer Abdul Rahman al-Sufi, who described it as a small cloud in his 964 AD Book of Fixed Stars. Later, in 1764, the French astronomer Charles Messier added it to his famous catalog of fuzzy objects to avoid while hunting for comets, designating it M31. M31 is a massive spiral galaxy, very similar to the Milky Way, though seemingly larger. It's our closest galactic neighbor of this scale. Today, we estimate the distance to Andromeda to be about 2.5 million light-years. Thanks to this relative proximity, it spans a massive portion of our night sky. Unfortunately, our human eyes are poor telescopes, so you can only see its bright core. However, with long exposure photography, its faint outer regions emerge. A stunning wide-field image captured by an amateur astrophotographer from Arizona shows Andromeda covering over 2 degrees of the sky, meaning it appears at least 4 times larger than the full moon. And that isn't even the whole galaxy. Currently, M31's disk diameter is estimated at 220,000 light-years, potentially hosting up to 1 trillion stars. This makes it roughly 1.5 times the size of our Milky Way. But estimating the mass of these cosmic giants is incredibly tricky. If you apply Newton's law of gravity and Kepler's laws, you'd expect stars at the galaxy's edge to orbit much slower than those near the dense core. Yet, in the 1970s, American astronomer Vera Rubin and her colleague Kent Ford proved this assumption wrong for Andromeda. The stars on the periphery were moving almost as fast as those near the center. The visible matter simply wasn't enough to hold the galaxy together at those speeds. The momentum should have ripped it apart. This groundbreaking research across dozens of galaxies confirmed the existence of dark matter, invisible mass that interacts only gravitationally. Weighing a galaxy with this hidden mass is immensely complicated. Different methods yield wildly different results. In 2018, scientists agreed both galaxies were roughly 800 billion solar masses. But in 2019, ESA's Gaia data suggested the Milky Way might be up to 1.5 trillion solar masses, nearly twice that of Andromeda. If true, we might be the ones eating Andromeda in the future. Yet a recent study revised the Milky Way's mass back down to just 200 billion suns. Determining galactic mass is a constant puzzle. Speaking of complex tasks, recently I've been building a model space station with my son. We got a fantastic STEM Space Explorer kit, and it's been an incredible bonding experience. We built a Mars rover, a lunar base, and launched a model rocket in our backyard. If you have kids who love space, I highly recommend checking out educational space kits. They are a perfect way to inspire the next generation of astronauts. You can find the links to our absolute favorite kits right down in the video description. Now let's return to the breathtaking visual structure of Andromeda, a magnificent barred spiral galaxy. Even though we view its disk at a tilted angle, its spiral nature is unmistakable. You can clearly see stunning dust lanes, which appear sharp on one side and somewhat faded on the other. This visual effect happens because part of the galactic disk sits behind the bright central bulge from our perspective on Earth. Millions of dim, older stars slightly obscure our view, muting the distinctness of those dust lanes. However, when we observe M31 across different wavelengths, like ultraviolet and infrared, the spiral arms dominate the imagery. Hot, young stars within the arms emit high-energy ultraviolet photons. As they heat the surrounding gas, it glows intensely in the infrared spectrum, revealing the galaxy's hidden architecture. The most detailed image of Andromeda we possess was released by the Hubble Space Telescope in 2015. It remains the largest Hubble image ever published. Capturing just a third of Andromeda's disk required the telescope to reposition 411 times, taking over 7,000 exposures. This spectacular 61,000 light-year panorama contains over 100 million individual stars and thousands of star clusters. On the left, you can see the dense galactic bulge populated by older, cooler stars. Sweeping right, you traverse intricate dust structures, ending in the sparse outer disk where bright young stars trace a giant blue ring. This ring of fire is where Andromeda's primary star formation occurs. Why there? It could be the result of constant gravitational interactions with its smaller satellite galaxies, compressing the gas to spark new stellar generations. The largest star-forming region in M31, and the entire local group, is NGC 206. Spanning 4,000 light-years, it contains a stellar mass of 200,000 suns, including over 300 incredibly hot, massive blue giants, younger than 10 million years. Despite this, both Andromeda and the Milky Way are actually experiencing a cosmic midlife crisis. A 2011 study comparing their colors to thousands of other galaxies revealed that their star-forming fuel is depleting. In about 5 billion years, both will essentially stop giving birth to new stars. Andromeda boasts over 450 globular clusters, 3 times more than the Milky Way. These dense spherical clusters hold hundreds of thousands of ancient stars aged 11 to 13 billion years. The largest, Male 2, contains millions of stars and might actually be the stripped core of a dwarf galaxy devoured long ago. At Andromeda's center lies a double nucleus mystery. Hubble revealed the true dimmer center houses a supermassive black hole exceeding 100 million solar masses. The brighter offset region is now believed to be an optical illusion caused by a cosmic traffic jam of old red stars stuck on highly elliptical orbits. Surprisingly, a ring of young blue stars tightly orbits this turbulent black hole, baffling scientists. This structure results from a highly predatory history. A giant stellar stream hints at massive past collisions. Supercomputer models suggest that between 2 and 3 billion years ago, Andromeda devoured a third major spiral galaxy in our local group, likely leaving the compact satellite M32 as its leftover core. Furthermore, its roughly 24 satellite galaxies inexplicably orbit in a highly organized flat disk, challenging current cosmological models. The colossal collision between Andromeda and the Milky Way is inevitable. Although their physical merging is 5 billion years away, the process has already started. In 2020, scientists discovered Andromeda's invisible halo of ionized plasma extends 1.3 million light-years outward, meaning it is actively bumping into our galaxy's own halo. When Milkomeda finally forms, actual stars colliding remains highly unlikely due to vast cosmic distances. For now, remember that the Andromeda light you see today is 2.5 million years old, originating when early humans first walked the Earth. Thank you for your continued support, likes, and comments.